Hello and welcome to this network education video. My name is Russell DeLong, and this is Evolved Mobility Management. As you'll see in this video, a user's state, whether they are active or connected or have a session, can be kind of ambiguous in the Evolved Packet system. So this video will be going over some of the theory behind Evolved Mobility Management and how it is distinct from, yet still related to, session management. This video seeks to cover an overview of location, network, and user identifiers used for mobility management, a breakdown of EMM states that a subscriber can be in, and what the implications are for each of those states, as well as an overview of common EMM call flows. So, mobility management itself deals with keeping track of users as they move around, as they move between towers, as they move between radio technologies, and as they move between roaming operators potentially, all in such a way that you're still able to provide the user with the services that they expect from the home mobile network. So keeping track of and managing user mobility. Again, kind of the name is the recipe, mobility management. It deals with keeping track of where registered users are, where a user's location identifiers are hierarchical, and we're going to talk about user location identifiers in upcoming slides, where the user's location is known with different levels of precision depending on what state the user's device is in from the perspective of the network and what radio technology they're using. Mobility management is the responsibility of the mobility management entity, the MME, for EPS services. Again, the name is kind of the recipe. And for previous architectures, it was the responsibility of the MSC VLR for legacy circuit switch networks and of the SGSN, that is the serving GPRS support node for legacy GPRS network architecture. While terminology may vary between these three architectures, that is circuit switch, GPRS, and EPS, mobility management concepts are extremely similar across the board, and if you are already familiar with either of those, circuit switch or GPRS mobility management, you'll be very much at home here. For the most part, we are applying new terminology to existing concepts. So EMM itself can be broken down kind of like this. Here I'm just sort of going over the hierarchy. The green line is the user's simple registration status with the MME, where the user is either EMM registered or he's not, either registered or deregistered, as the states that you can have within EMM. If a user is registered with an MME, he can have one of two connection states, or these ECM, the red line. An ECM connected user is one that is tied to a specific cell at a specific tower, a specific eNode B. He has a user-specific UE context, this blue line between the eNode B and the MME. So really, the red, if he is ECM connected, it means he has the ability right now to talk to an MME. He has a stateful connection with the MME to facilitate talking to the MME. That is what ECM Connection Management deals with. Now, if the user is not connected, he would be ECM idle. So within EMM, you have kind of the substates of ECM idle and ECM connected, where users naturally, as they move around, or as they don't have a need to be talking to the MME right now, or if he doesn't have an active session going on right now, the user will transition into an ECM idle state. Now, ECM idle and connected relate somewhat to session management, but we're going to talk about that in a moment here, and that actually brings me to this next slide. These are the connections that are not really within the scope of this discussion. These are the connections that relate to session management. The way to sort of break these two down, and it gets a little bit confusing, especially if you're looking at in actual packets of messages between eNode Bs and MMEs, because a lot of times one field of information will be EMM information, and another field of information will be ESM information. But the way to sort of keep the two straight, the goal of evolved session management is the end goal. It is to set up, maintain, modify, or tear down IP sessions between users and destination IP networks. So if you want to create a new EPS pair, a new end-to-end connection between the user and the internet, that would be an ESM type of request. So if I'm sending a message that might have some mobility management stuff in it, like where I am and what I'm doing, and I also am sending a field that says I want this particular QoS parameter changed for this particular session towards a destination network, that would be an ESM type of piece of information within a message. So two different goals, one to manage the user's movements, and the other, ESM, to manage the user's ultimate IP sessions in these towards these destination IP networks. But I do hope that you get a sense when you look at these two diagrams where almost all of these lines are their own independent, stateful, user-specific connections between these endpoints. That is, if I go up here, this eNode B has a specific UE context with a specific UE context ID, that blue line, towards that MME, and vice versa. So they are tracking each other with stateful. This is its own independent stateful connection. RRC is its own independent stateful connection. ECM itself is stateful. S1 bearers, you have user-specific tunnels with specific tunnel endpoint IDs that have state. So to ask a question like, does the user have a session? Is he connected to the network? It becomes very ambiguous, and you really need to be clear on what the person asking that question is really talking about. Are they talking about, can they open a web browser and get to a page? Are they talking about mobility management? Are they talking about a specific tunnel? It becomes very ambiguous to have those conversations, and this is just, I hope that I have kind of demonstrated that with these two slides here. This is pretty well all I'm going to say about ESM because it's a separate discussion, but I did want to include it here just because by their nature they can become easily confused. And it actually, I'll talk about it in this one little bit on this here as we go into ECM Connection States. So as users move and do different things, this is sort of to drive home the flow of how users are going between idle and active states. So the user will go into an ECM connected state when he registers. Just the simple act of sending an attach request to say, hey, I want to register with the MME is going to transition him into an ECM connected state to set up that exchange. When a user sends a periodic tracking area update, which is a keep alive, if the user is idle for a very long time, there's a timer that's going to be given to the user on registration by the MME to say, if you have no other reason to talk to me, you have to at least report back within this amount of time so I know you're still here. That's a periodic tracking area update. He will transition to ECM connected to send that message. The MME, when it needs to page the user, is going to transition it into an ECM connected state. A page, it's a little bit easier to understand in a circuit switch network, I think, when we're talking about voice calls. So when you need to receive a voice call when you're idle and you're not really tied to a specific tower and you're not actively talking to the network, a page makes sense because the network needs to reach you in order to terminate that call so that you can actually receive the call that someone is trying to get you on. So it makes the same sort of concept still applies in IP networks, but in a sort of less intuitive way. If you have a server that's trying to send messages towards a user device that may be in an idle state, so if I go back up here to ESM one last time, if some destination IP network, let's say this is VoIP, just to go back to the voice call thing, if we're talking about VoLTE IMS or something like that, if you're receiving a voice call and that IP packet comes into the P gateway, destination IP address of the user, well, he needs to reach him, but because the user is ECM idle, that would mean that he might have this S5, but he won't have this S1 bearer. If you think about it, ECM idle means the user is not tied to a specific eNode B, which means this whole area doesn't really exist right now, not specifically for that user. So it needs to be created. So S gateway will say, hey, I don't have an S1 tunnel for the user, so he'll talk to the MME, and that's going to trigger that page procedure. So then he's going to transition to ECM connected. Then with the MME able to talk to the user and tying him to the eNode B, then the MME is going to be able to tell the S gateway, hey, we're going to set up a tunnel between this specific eNode B and this specific S gateway. So this is kind of how ESM and EMM work in tandem. Because the user was ECM idle, the MME would have told the S gateway, hey, your ESM stuff, you've got sessions for this user, but because he's his mobility management, he's no longer in a connected state with me, he's no longer tied to this eNode B, he's moved away from it, so you can't really have this tunnel towards this eNode B and expect it to be able to reach this user. That's sort of how they're working in tandem while being separate things here. So that's pages, sorry. User sends a service request. So aside from just attaching to the network, if the user wanted to get multiple or different EPS bearers, or if he wanted to modify the nature of an EPS bearer, like change QoS settings for whatever reason, those types of messages, because he needs to talk to the MME, and you got to remember, the MME is the one that's constantly telling the S&P gateways what to do for Evolve Session Management, even though the Mobility Management entity, the MME, is mobility, he also has ESM responsibilities, and the user's only avenue to talk to the packet network to change or create or tear down these IP sessions is through the MME. So even for ESM service requests, they do go through the MME, and you do always need to be ECM connected to have these types of sessions being set up. Movements to ECM idle state. The MME releases S1 AP UE context. So, and again, okay, I'll talk about it in a sec here. So UE releases RRC connection, or eNode B releases S1 UE context and RRC. So just to go back up here, the orange, the blue, they can both be torn down. The MME can tear down a UE context. He's going to do that, for example, at the end of a transaction. Let's say we're doing a periodic tracking area update. Well, for a periodic tracking area update, the user is only doing it because he was told by the network, you have to update me within this time period. The user at this point wouldn't have any ESM services, otherwise he wouldn't be he wouldn't have any active ESM, he wouldn't have any full EPS bearers built at this point, because if he did, he wouldn't be ECM idle and he wouldn't need to send the periodic tracking area update. So if he sends something like that, a periodic tracking area update, the MME would typically tear down the UE context at his level to transition the user down into an ECM idle state immediately at the end of that procedure. So for a very start-stop procedure, the MME might be the one to do it, and he'll do it at the UE context level. The eNode B could do it if at the RRC level there's a timeout or something, or if he loses track of the user, he could tear down both sides and say, okay, the user's gone. He'll send a UE context release to the MME, and he'll send an RRC, or he'll release the RRC channel for the UE, and that will transition the user into ECM idle. And then the user himself can transition himself to idle. So the user is actually really, for most procedures, I think, in the best position to do it. If the device knows it doesn't need to download anymore, or it doesn't need to keep talking to some destination IP network, and he knows he doesn't need to send any tracking area updates, then there's really no reason for the device to keep radio resources tied down for these sessions, so he'll transition himself out of ECM connected state, and that'll tear down all these tunnels as well. Alright, so EMM state changes, the user registering with the MME, the user deregistering with the MME, and the MME detaching the UE. So, simple example of detaching the UE from the MME's perspective. We talked about periodic tracking area updates. Well, if the device stops sending periodic tracking area updates, so if the device does not update the network anymore, let's say the device is either out of coverage or turned off, eventually that'll time out and the MME will deregister the user, in which case he doesn't even have this green. He'll be deregistered at the green level here as well. Alright, so mobility states in the EPS. So EMM registered, this is just it's kind of a little bit of a repeat of what we just talked about, but just to drive it home a bit. So EMM registered, ECM connected. The HSS will actually, I kind of left that out earlier, but the HSS will get updated when the MME registration happens. So as soon as the MME is registering the UE, he's going to send a location update to the HSS to say, I am now the serving MME for this user. So the HSS is always, or should always, have a current record of the last registered MME. The MME knows the user's location with cell level precision. It says current MME. I should say the last known MME registered. That's more accurate. Because the MME didn't necessarily purge the user towards the HSS. That's a separate thing. So the MME knows the user's location with cell level precision. When he's ECM connected, it is cell level. So the eNode B will actually communicate that, and the MME is going to keep a record of that, and he's even potentially going to tell the S gateway and the P gateway that for records. But MME knows cell level precision. The MME has established a UE specific UE context with the eNode B serving the subscriber, and the UE has established an RRC control channel with the eNode B. Again, ECM connected means you're tied to a tower. Idle means you're not tied to that tower. It's the simplest way to look at it. So if he's idle, HSS has the current MME, again last known, user's registered with. MME knows the user's location with tracking area level precision. We're going to talk about this distinction, a list, near the end of this video. There's no eNode B tied to the user, and the UE does not have a radio bearer. So at an ESM level, at a session management level, if you are ECM idle, that means you don't have an S1 bearer. So this, again, this whole area here, if you're not tied to a tower, this whole thing is gone. And all related sessions therein. Oh, sorry, I am flipping slides here. EMM deregistered. So the HSS may know of the last MME the user registered with. The last registered MME may know previous state information, and I'm going to talk about GUTIs in a little bit here, but has no current state information that could be relied on. The user may be unpowered or out of coverage, etc. So basically the user's connection is timed out. We don't really know where he is. We may or may not know where he was last at some point previously. We may have kept historical information on that, and that's going to depend on the MME and HSS implementation, the vendor, and everything else. Geographic location breakdown. So the GERAN and the UTRAN, the UMTS Terrestrial Radio Access Network, I sort of broke it down by radio technology here. So it is hierarchical and it is logical. It's just a lot of acronyms. So in the world, there is a country. MCC, Mobile Country Code, identifies the country. In that country, there is a network. So MNC, Mobile Network Code. Within that mobile network, there is a location area, identified with a location area code. In the location area, there is a routing area, identified with a routing area code. And in the routing area, there is a cell identified in the GERAN would be CGI, and in the UTRAN would be SAC, Serving Area Code. You'll also see reference here to SAI, RAI, and LAI. All those are, whenever you see the I, it means you're including the MCC, MNC in that value, whereas the RAC or in the SAC is just that one specific part of it. So, for example, LAI would be MCC, MNC, LAC. Combination of those three would be the LAI. Same idea for the evolved UTRAN. So this would be the LTE radio network. So here we're talking specifically about EPS was originally meant to serve for in Release 8. So in the world, there's a country, MCC. In the country, there is a network, MNC. And here we're slightly different. In the network, there is a tracking area, or identified with a tracking area code. Same sort of deal with LAC and RAC. And in that tracking area, there is an evolved CGI as opposed to CGI. But it's the same concept. One minor note, when I was talking about tracking area updates and periodic tracking area updates, the MME will ask for updates when the user moves between tracking areas. So for the purposes of paging, when you page the user, you page the tracking area of cell sites. It's a logical group of cell sites. A LAC is also a logical group of cells and RNCs, and a RAC is also a logical group of cells and RNCs or / base station controllers. So when a circuit switch network wants to page a user, he pages the LAC of cells, you can say. And when a GPRS network wants to page a user, that network or the SGSN would page the RAC of cells. So if you know the last known routing area of the user, you'll page all RNCs / base station controllers that serve that routing area, and all of those systems will page all towers that serve that routing area to try to reach the user. And same deal with tracking areas. So for user identifiers, you have the globally unique temporary identifier, or GUTI. This is a little bit different than what existed in previous networks with TIMSIs or TMSIs. So circuit switch network, you just had the TIMSI. You had the P-TIMSI or packet TIMSI assigned by an SGSN in a GPRS world. Well, here we have something a little bit different, and that is the GUTI, the global unique temporary identifier. It's just a lot bigger here. So in the world, there's a country, same sort of breakdown. In that country, there's a network, mobile network code. In the network, there is a group of MMEs identified as an MMEG number, and then within that group, there's an MME identified uniquely as an MME with an MME code number, MMEC. And then within that specific MME, there's a temporary identifier for this user, and that is the MME assigned TIMSI or M-TIMSI. The idea behind this hierarchy and how it is logical is if you see a GUTI, a GUTI value, anywhere in the world, you should be able to figure out what country it's in. And then within that country, a system should be able to figure out what network it's in from the network number. And then within that network, well, that network should know its own MME group numbers. And then within that MME group, every MME in the group should know about the specific MMEC, the specific MME that is being identified here. And then that specific MME in the world should know the temporary identifier that it personally assigned to this user. So the hierarchy allows you to map it all the way back to a user uniquely across the whole world no matter what. That's sort of the idea. You'll also see reference to TIMSI, SAE, System Architecture Evolution TIMSI, a reference to the project name that created the Evolve Packet Core, TMSI, Temporary Mobile Subscriber Identity. The reason you'll see STIMSI is because it's what is sent in some types of messages. I seem to be mentioning periodic tracking area update more than I intended, but a tracking area update would often use an STIMSI as opposed to sending this entire identifier, just because it's simple and short and you're already talking to a given MME. Worst case, you go to a second MME, but if he's in the same group, again, he sees the MMEC number and he knows what MME he can talk to make sense of whatever message you just sent him, because he's able to relay that via what's called S10 interface between two MMEs in the same group. So if you wanted to prevent the user from needing to re-authenticate, let's say, if he moves to a new MME, just because he's sending these two values, just these two, it's enough information for one MME in that group to figure out what other MME he needs to talk to get your security information to avoid going through another round of authentication towards the subscriber. The GUMMI, GUMMEI, all that is basically the first four identifiers that I just talked about. So I just mentioned how an MME is uniquely identified in the world. Well, that's this breakdown here: country code, network code, group number, and then the code number for a specific MME within that group. That's all that is. So location update procedures, devices to mobility management systems. Tracking area update would be, I talked about this already. So tracking area updates are towards MMEs. Periodic tracking area updates would be the keep alive. Location area updates would be towards circuit switch mobile switching centers, and routing area updates towards SGSNs. Mobility management systems towards location registers. Here I'm talking kind of generically when I say mobility management systems and location registers. So in the context of EPS, we're talking about S6A interface, location update between an MME and an HSS. The same sort of concept, again, for location updates between an MSC VLR and an HLR in a circuit switch network. And the same concept, again, for a GPRS location update between an SGSN and an HLR. So really, I'm just sort of driving home here how it's the same thing as previous mobility management concepts, just being applied in a new way with new terminology and new protocols, actually. But it's the same concepts again and again and again. Tracking area lists, I wanted to talk about this briefly. I mentioned how tracking area updates are done at a TAC level. Well, when the user registers and the MME says, this is how long you have before you need to update me, he also has a condition where, regardless of how long it's been, if you are crossing tracking areas, you have to let me know, because I need to be able to page you. And when I page you, I page a tracking area. That's how it was in previous architectures, but it's been made a little bit more flexible with Evolve Packet System. Instead of saying, user, you need to update me if you change tracking areas, the MME can keep a user-specific list of common tracking areas or last known tracking areas. For example, if you had a user that was constantly moving, let's say he lived in tracking area 1 and he worked in tracking area 2, and let's say there's another user that lives in tracking area 5, frequents tracking area 3, and goes to tracking area 6 fairly often as well, and this is kind of his normal behavior. Well, the MME might keep track of last known, or maybe a tracking area list of previous tracking areas. So if user 1 moves between tracking area 1 and 2, that's okay. we might send a tracking area list, the MME might, that is, to say, okay, user, when you're registering, based on your previous registration, the last known tracking area you were in was 2, and before that it was 1. So when you are moving around, you only need to send me an active tracking area update to tell me about a change in tracking areas if you cross something other than 1 and 2. So if I need to page you, I'm going to page both tracking area 1 and tracking area 2. Now, there is a trade-off between tracking area update optimization and paging optimization. So the bigger your tracking area is, the fewer tracking area updates you're going to have, because users aren't able to as easily move between tracking areas, but the larger the scope and the larger the cost of every page message you have to send. If you have to send a page to every cell site and every cell for one user, again, there's a trade-off there. So the smaller your tracking areas are, the smaller the scope of your page messages, but the more frequent your tracking area updates. So tracking area lists is a concept specific to EPS, and it gives you a little bit more flexibility to optimize this a little bit further. So you can have small tracking areas to have a very small scope for your page messages, but at the same time it allows you to have sort of an optimal update procedure as well, because users aren't constantly needing to send you tracking area updates as they move between common tracking areas that they would normally frequent. And that's kind of the idea here, the optimization of tracking area updates and paging procedures. So that's basically everything that I wanted to cover in this video. This was just sort of an extra slide if I wanted to talk about the EPS. That's basically everything I wanted to cover in this video. I know EMM is a huge amount of theory, and some of it's a little bit simplified, and it can often become confusing when we're looking at ESM and EMM in tandem, because one relates to the other. Because a session is torn down, I no longer need mobility management to be in a connection state, or because mobility management has just transitioned into idle, I can no longer have these full EPS bearers and need to turn those down. We're constantly talking about these sessions hand in glove, so to speak, but they are distinctly different things with two distinctly different objectives, and that's just sort of what I was hoping to cover here. So I hope you have found value in this video.